G'day everyone, my name is Gary and today we're going to learn how to use Python to code your LEGO Mindstorms Robot Inventor set. So today we're going to learn a little bit about the principles of coding using Python. Python is an incredibly useful language to learn, and it is also really fun to do. Once you've started learning how to code in Python, you'll find that your code will be a lot neater and a lot easier to read. Python is also a really useful language because people use it for data analysis, for making apps and websites, and a lot of other things as well. So Python is really cool. So let's dive straight into it. Before we get started, we want you to build the robot Tricky. Okay, so in case you haven't seen where Tricky is, then you open up the Robot Inventor set, the Mindstorms software, and then you build Tricky over here. It's the second model from the left. You click into it, and then it'll say introducing Tricky for step 1. And we're going to dive straight into step 1. We're going to start and then hit the build button right here. Okay. Once you hit the build button, you'll get your instructions, and then I want you to make sure that you build every single step really carefully and make sure all the cables are plugged into the right place as well. That's going to be really important for you to follow this lesson. So after you've built Tricky, then let's take a look at the robot. Here you can see that Tricky has 2 wheels, okay? So one on the left side and one on the right. And each wheel is controlled by a motor, okay? This is going to be really important because if both of the wheels are moving in the same direction, for example, if this right wheel was moving forward and this left wheel was moving forward at the same speed, then this robot will be moving forward in general, okay? And then vice versa, if we reverse the wheel on the right and reverse the wheel on the left, then this robot will be moving backwards, okay? But what if we want to turn? Well, if I was moving forwards and I wanted to turn to the right, then all I'll need to do is slow down the motor on the right-hand side. What will happen is if the motor on the right slows down, then the motor on the left will keep on moving forward, and this robot will do a turn towards the right. If I wanted to turn towards the left when it was moving forward, then I would slow down the left wheel, and then it will turn towards the left. Pretty simple so far, right? This is a really cool little robot because it is very small, it's compact, and it's quite feature-packed. It also has this distance sensor up the front. This distance sensor is going to be really important for our first lesson to make sure that we learn how to use a distance sensor so that our robot can stop crashing into things and make it more smarter than your average toy car. Okay, so let's go into the code and have a look. Before we get started though, I want you to press on this middle button on Tricky, and you'll see the lights pop up. There we go. So Tricky is activated. Now let's go into the code. So in order to get started with Python, what I want you to do is go into Projects, then scroll down to the bottom to go Create a New Project. Create a new project. And now it's going to have Python, word blocks or Python. So Python is what we are going to use today. Click on Create. And now, once you're inside Python, there's a whole bunch of stuff that's written here. Up the top, we have some imports. What these are is that if you imagine Python as a language, right? Python doesn't have all the necessary functions in order to run your Lego robot, because Python is its own language, right? But in order for it to interface with the Lego specific methods and functions, then what it needs to do is we need to start importing some important classes, right? We import some classes like functions to do with the motor, how to handle the sensors, and all the different things that the Lego robot needs to use in order for us to code using Python. So that's what all the import information up the top is for. For now, you don't have to worry about any of the things on the top. Everything on the top here, all the things that is imported up here is the complete package of what you would need in your Spike Prime robot. Why would they do that? Why don't they? Why don't we just keep it all imported all the time? Why would we want to remove any of this? Well, the reason we would want to potentially remove any of these is for memory issues, because when you import some of these new methods or some of these new classes into your program, then it takes up space. Okay, so if your robot starts to run out of space, then it might be worth looking at some of these classes and removing them if you're not needing them for your project. But we'll talk more about them later on. Over here, we have our first comment. Okay, so this purple text here that starts off with a hash symbol or a pound symbol, that means that it is a comment. It is a bit of code that is meant only for humans to look at. So it's when Python is running through the program, reading line by line, and it reads this hash symbol, then what it's going to do is it's going to skip the rest of this line, okay, because it's not going to read it. But what it's there for is it's there to give hints to the programmer. So here it's telling you to create your objects here. All right, this is where we can write down our variables and also name our objects. Okay. So here, hub is our first object, and it is equal to MS Hub. And you'll see that MS Hub was imported from up here because Python doesn't know what MS Hub is, right? Mindstorms Hub is something that Lego came up with. So in order for us to code Python on this Lego Hub, we need to import the Mindstorms Hub class before we can define it. So here, hub is the name that we have defined this object. And then down here is another comment to say to write our program here. Okay, so here it's telling the hub, which is what we defined up here. So the Mindstorms Hub dot speaker dot beep, open and close brackets. What does hub.speaker mean? Well, that means that it's saying within the hub, look for something called a speaker. Okay, so the dot notation is there to say that that speaker belongs to hub. Okay, so we go backwards from that. So in short, we say, okay, we look for our hub, which we know is the Mindstorms Hub because we defined it up here when we created our objects. Then we say, look for the speaker in the hub. And we know that speaker will exist because all Mindstorms Hubs have speakers. Dot beep. So in the speaker parameter, we will find a beep command, okay, or a beep method. So we know this is a method because it's got open and close brackets. So anything that has open and close brackets like this is a function or a method, and it does something, or it's something that will potentially you can put variables in or arguments in there, and it will do something for you. Okay, so all this code is doing right now is it's saying to create a hub, and we're defining it as a Mindstorms Hub. And then down here, we're saying to tell the hub to look for a speaker and telling the speaker to look for a function called beep. Okay? So if I run this program and it's running properly, then the robot will just make a beeping sound. Okay, so let's, my robot has fallen asleep, so I'm going to turn it on again. And then what I want you to do is go up to the top right, get to the hub connections. We're going to Bluetooth, and then hit the Bluetooth button on top of your Mindstorms Hub. So if you have a look at your the top right of your Mindstorms Hub, you'll see this little Bluetooth symbol. Click on that, and then it's going to start beeping and flashing. We go back into our Mindstorm software, and then we go connect. Okay. Well, you might say to update the motors. Just in that case, you just update all the motors. Okay, so we press this play button, and it'll make a little beep sound. Did you hear that? It was very, very faint. I'm not sure if the microphone picked it up, but it made a little beep sound, which is great because it means that your code is all working. So let's hit this stop button, and let's continue with doing some cool code. So here, our hub is, like I said, this is the name of the object. So this could be named whatever you want. Okay, so this hub could be anything you want. Maybe I'll go. This is called tricky. Yep. So then tricky is just the name of this hub, and we know that tricky is a hub because we defined it as a Mindstorms hub over here. Okay. Another thing we can do is we can save our project. So rename our project. We'll call this project CA Python 1. That way we'll know that this is the first lesson for our Creator Academy Python series. So Tricky is now a hub, and we went Tricky's speaker is making a beep. So that's great. But now we want to do something cool. Let's make Tricky move. Okay, so you know how in Spike Prime we have, in the word blocks with Mindstorms Robot Inventor, we have code blocks, right? We've got these movement motors, and we set them as movement motors. So these are like motor pairs. And what these do is that it makes it easier for us to code to make the robot move forward and backward and turn around. So let's do the same thing. So we go movement motors equals, and then we'll create a motor pair. Motor pair. And you'll see this is called code hinting. Okay, you'll see how when you start typing code, it will pop up with suggestions. And this makes it so that it reduces the amount of typing you have to do, and it also reduces the errors from mistyping. So here I see motor pair. I click on that. And then the way we do motor pairs is we go open bracket, and then we look at the two motors, okay? So the left motor is always first, and then the right motor is always second, just like in the Scratch language. So left motor is on A, right motor is on B. And in Python, we have to put quotation marks around the letters because letters are strings. And I'll tell you why in a moment. So A and B. Okay. Why do we need quotation marks around the letters? Well, because the letters and words in Python are known as something called strings. Okay? If I don't put a quotation mark around it, then what it's going to do is it's going to look for an object called A or B, right? Just like how we've defined an object called Tricky here. Yeah, we don't use a quotation mark around Tricky because Tricky is an object. And if I didn't have my quotation marks around A or B, then it will think that A or B is an object, which is not the case. It is the letter A or the letter B. So to make a move, we go movement motors dot move, and then we have to put in 3 separate arguments in here, or 3 separate parameters into these brackets. And each parameter is separated by a comma. Okay? What comes first? The first is the number value that we want to move. Let's say we want to move 20 centimeters. So the first one is going to be 20. And then we put a comma in. And notice that numbers also don't have quotation marks. Numbers are just written as the number. So 20. And then the second parameter is going to be the unit that we're using. So here we're going to go centimeters, cm. And that is in quotation marks because that is a string. And then after that, we give it the steering value. So just like how in Spike Prime, in the Scratch code, how you say negative 100 is turning all the way to the left and positive 100 is turning all the way to the right and 0 is going forward. We can put 0 here, but we have to go steering equals 0. And that will make it move forward 20 centimeters. So let's try that. Press the play button. And then there we go. Okay, I'll give you a closer view of that. See how it made a beep and also it moved forward. So that is really cool. We already got some code happening. Let's crank up the difficulty a little bit. Let's say we want to move forward, but then stop when we detect an obstacle coming towards the robot, so that it's a bit smarter, so that Tricky can be a little bit smarter. Then all we have to do is do a very small change to our code. So let's have a look. Here we make a beep and we started moving forward. But instead of moving forward a fixed distance, we're going to comment this out with a hash symbol. And then we're going to tell it to just start moving. So movement motors, dot start. And then that's going to just make the movement motors start moving, okay? And then they're not going to stop. But we want it to stop once it detects a obstacle coming closer to the distance sensor. So what we need to do is we need to now go and create our object for the distance sensor. So here we go, distance sensor equals. And then we go capital D, and then here you'll autocomplete and say there's a distance sensor. Yep, that's good. Oh, whoops. Distance sensor. And then we have to tell the robot where the distance sensor is connected. And then we go D in the quotation marks. Back down here, we go, as we start the motor, we're going to say distance sensor. So make sure this is the lowercase distance sensor, which is the object that we created. Dot wait until. Oh, well, actually, we're going to use this special one. We're going wait for distance closer than. And then we're going to put in brackets again. We're going to say 10 comma centimeters in quotation marks. And then what do we want to do after we detect an obstacle coming in? We go movement motors dot stop. So what are we saying here? Right at the top, we are importing all the classes for Mindstorms. And then here we're creating our objects. First we tell the code what our hub is called. Our hub is called Tricky. Then we set our movement motors to be A and B. Then we set our distance sensor to be distance sensor D. That's all really easy, right? Then we write our program. We make a beep sound. Then we tell our movement motors to start rolling. And then we tell the distance sensor to wait until the distance is closer than 10 centimeters. So if it detects an object approaching closer than 10 centimeters, then the movement motors are going to stop. Okay, so all you have to do is stop that last code and then press the play button, and then hopefully it's going to just roll forward and then stop when we detect an obstacle. Yep, that works. I'll give you a closer view. Okay, so it will stop once it detects an obstacle coming in, which is really, really neat. So that's it for our first lesson. We learned how to get started using Python on the LEGO Mindstorms Robot Inventor set. We learned how to import different classes, which happens automatically. And we learned how to name different objects. So we learned how to change the name of the hub, and we learned how to define the movement motors. We also learned how to identify the distance sensor, and then we learned how to make the robot move and also stop when it detects an object in front of the distance sensor. So I hope you enjoyed the lesson. If you liked it, then please like and subscribe to my channel, and I'll see you next time for more Python on the LEGO Mindstorms Robot Inventor set. Bye bye.